Hey, folks online, can you hear me?
Yep.
Perfect. Give me a quick second. We'll get on moving. Sorry for being a little tardy today. Okay, so I guess first thing first, logistics. How did recitation 1 go? Did most everybody get their setup working and running code? That's kind of the most important thing to hit off. If you did not, can you guys hear me okay? I'm getting a couple people are saying the audio is pretty bad. Okay, then. Okay, only one of you can't hear me very well, so that's probably on your end then. If I do start cutting out, let me know, and it's probably my hotspot doing something funky. So just say something if you can't hear something. I'll be happy to repeat. Obviously, we got kind of a weird setup. So anyway, cool. Yeah, so it sounds like recitation went generally well. If your setups weren't working, please get a hold of the TA or the CA pretty quick to deal with that, because the homeworks are going to start slinging out pretty quick. We're gonna have to be getting them done pretty quick these first few weeks, because it's just a faster pace kind of thing. I just had a thought about that. Anyway, I don't like that thought. It's about daily homeworks, and you guys don't want to do that. That's too much. Quizzes are enough.
When's this one due?
The homework that I put out, yeah, so that's a good question. So homework 1's out. It is due. I put it out a little late, so I made it due Friday, I think at midnight. It should be at midnight on Friday, meaning like Friday at 11:59. That's plenty of time to get this done. You'll get another homework probably on, I guess tomorrow's probably on Thursday, kind of when we finish up the week. That I don't know if I'll expect you to have done before Tuesday, probably. So probably another one assigned Friday that you'll should be able to do by Tuesday with some extra instructions on syntax and stuff, because you guys won't meet with Sakani again until Monday. So we'll figure out the logistics that later. But yeah, again, like I said, it'll be 2 homeworks. One will be mostly over the weekend with maybe 1 day of class, and then 1 during the week on paper. This first homework isn't super horrible. You guys should be able to do most of it without any big hiccups. The bonus problem is kind of tricky. And you might need to look into some extra syntax to make it work. I don't think you do, but you might actually have to define 2 functions to make it work. So just have that kind of in the back of your head. Do you have a question?
No.
Okay. Let's see. I don't think it's taking submission. Oh, Linnea, thanks for saying something. I will double check. I think I know why that's not working. Let me write that down. Otherwise I'll forget. I think I didn't open up the submissions, so bear with me on that one. And I'll get that done tonight. Expect an email about that later. Other logistic type things. I know there was something else I needed to run by you guys. Yeah, please be posted on Piazza. I've been getting a lot of emails about stuff that should be handled on Piazza, so just please be diligent. If it is any way potentially pertinent to the entire class, which is anything that's kind of material based, please post on there. Same with the setups, post on there. Usually a solution will be on there. It takes some getting used to. I know, we're usually pretty good about, I check Piazza for sure once a day. The CA should be checking a little bit more often than that, so our response time should be pretty quick on those. Any other questions before we get started with material today?
So yeah, I might need help with the setup. The setup of VM. I'm having issues with that. Even if we can't do it after class, then anytime we can schedule an appointment.
Yeah, so try and get in. I know there are office hours Oh, that would have been today, I guess. With Sakanya, but otherwise there might be Wednesday office hours. Check online on Canvas. If not, shoot me an email and we can set up some time.
Okay.
Or with the other guys, email them and they should be able to get some time scheduled in with you. So.
Okay, thank you.
No problem. Otherwise, if there aren't any other questions, kind of your weekly reminder, we're doing back and forth still, so be active in chat. You know, for those of you online, go ahead and just speak up over the microphone. We can hear you in class, so just say something. We'll definitely hear you. Otherwise, let's keep this back and forth going. I had a really good week one with you guys, enjoying it. So keep up the good work. Yeah, let's jump into it then. So last week we kind of finished off with the definition of lists of numbers. And I think we did the length function too on it, right? Did we finish it, the length function? Maybe. I think we did. So let's revisit that. So we defined a NAT list.
Do you have a recording of Thursday's lecture?
I do not of Thursday's lecture because my laptop died on me mid-lecture. So no video for Thursday, but the notes are up. So that should give you a good idea what we went over.
Okay. All right, cool. Thank you.
Yeah, good question. Yeah, so we define that list to be, and actually even for the stuff we went Thursday, we'll cover a lot of it today too. So it shouldn't be, you shouldn't have missed too much. But anyway, NAT list, we defined it to be the empty list. I think, did I call it empty or nil? I think nil. I think I changed today calling it empty. Anyway, nil, empty for our purposes are mostly the same thing. So we have nil and then we have cons, which takes a natural number and a NAT list. Now, we defined bytes last week, right? Could we generalize using kind of a similar data type to do like binary numbers of any size? Could we use a similar construct? So to represent something like 0, 1, 0, but without all the extra. Or like maybe 1, 0. Or I guess 0, 1, 0 doesn't make sense, but like strings like this. Do we think we could represent that in a similar way, just using what we have here, defining a new type? And I'll write that down. What do we think? Could we do that?
Yeah, I mean, I guess like as a NAT list, you mean, sort of?
Yeah, not necessarily as an element of NAT list, but in a similar way, creating a new definition.
Yeah, I would say just the same thing, except the constructor would not be of another natural number, but of a Boolean.
Of a Boolean, right? So let's write that out. So let's call it a bool list, right? So new definition, we have bool list. And it has some constructors. What should we call the constructors? Well, we can leave it as nil again. I mean, it's kind of doing the same thing in cons. Why change a perfectly good name? And as you said, we'll instead use a Boolean and change that to bool list. Okay. And I could represent these strings above that I wrote. This becomes cons 1 of cons 0 of cons 1, con 0, empty. With a whole bunch of parentheses to close that out. Right, and I could do 1, 0 in a similar way. So now I'm not necessarily locked down to just like 8 bits in a byte, right? I could do any length byte string here. I could define interesting functions on that, right? I could define and or the bitwise versions of those, right? Now, how do we, let's say I introduce another new type that I'm just gonna give it to you. Can we do this for characters too? So we haven't introduced characters, but just use char in the normal way that you would. It's an ASCII character, right? But only one. So could we do lists of these or strings, right? Could we do this a similar thing? Right. So I can define strings in a similar way. I can say something like string is defined as, there's nil, the empty string, right? And then cons with a character followed by a string. And that's a list of characters, right? Same exact mechanism. It's no different. We're just creating a string of characters now. Now my question for you guys is, isn't this a bit redundant? Could we write this in a more succinct way, do we think? That captures the idea of maybe being a list? Because these are all constructed in the same way. They're all formed in the same way. What's the only difference? Well, it's kind of, there's a variable that's kind of in play, but what's the variable here? Can we circle it in each of these? Yeah, the type. So the type in here would be this nat. Up here, it's the Boolean. And over here, it's the character. So now, can we abstract that out? Well, sure, why not, right? So let's now define, I'll say yes. See yellow above. See, now I'm making the notes even easier for you guys to use. It's gonna be great for people showing up to class. I love it. Being sarcastic. Let's define lists in what we call a polymorphic way. So now you guys have probably seen this word before, polymorphic. We'll talk about what it actually means in a second. So instead, we could introduce a variable here, right? So you're kind of onto it when you first said there's a variable, something happening. So this time I'm just going to write list. And this will be the list definition we use for most of the rest of the class, not on homework 1, I don't think. So keep that in mind. But we have a list. I'm going to leave a little bit of space. So if you're writing in pen, don't necessarily write this down yet. And we're still going to have nil. Nil doesn't change. And we're still going to call cons cons. But what should go here? A hole, maybe? Not quite a hole, but I like how you're thinking. A type needs to go there because our constructors always have types associated with them. The type they take as arguments. So instead, I'm going to say, kind of, and why I left a space next to list is I'm going to introduce a variable with my kind of naming of the list. I'm going to say it's a list of A. Okay, so Put a little pronunciation note. Where A is some other type. So A is like a nat or a bool. It's not going to be something like 1, 2, or 3, right? Because that doesn't really make any sense. It's going to be of something. So a list of natural numbers or booleans or characters. You could have a list of lists maybe too. Say like a list of strings, that's a type of list of lists, right? And inside my cons, you suggested a whole. What should I put there instead now? A, right? So I have cons and an A. And then what goes here for the kind of the inductive or the recursive part? The inductive part is the right word, but that recursive piece. So up here we had string, up here we had bool list, up here we had nat list. So we had something list, right? Something list. So what can we put there? This is some nude notation, not super radical, but we're going to say it also takes a list of A. Yeah, and Linnea, good. You said A list. It just goes in the other order. So it's a list of A instead of saying A list. In languages like OCaml and ML, you actually do put the argument in front. You'd say A list. We just don't here because it doesn't read as well, in my opinion. And there's a bunch of programming languages based off the notation I use here that just do it this way. This is convention. So yeah, points to you, Linnea, for getting that one right. So sweet. So this is the, I'll label some of this. Recursive piece. This is an element of the list. This is also called the inductive part. Cool. Now, if I wanted to say from this, create, say, a list of numbers, how would I write that? So let's make a list. Let's create just the list 1, 2. Okay, so this is going to be cons 1, cons 2, empty or nil. Like so. Right? Is that any different from how I would construct that before? No, it's exactly the same, right? Here, instead, if I were to give this a type and give it a type annotation, I would say it's a list of natural numbers. This whole thing has a type. It's a list of nats. That's how you write it. So that A, you can actually fill it in and make it kind of more specific, maybe in a type signature. Say if I wanted to add together a whole bunch of numbers that were in a list and sum them up, I could, in the kind of function argument, I might say list of n. We'll write that in a minute. Yeah.
So you just have the nil thing there to signify that the list is over?
That the list is over, right on. Right. Because it always, cons always expects here another list to happen. And so if I don't ever stop it, it's like still expecting something. It wouldn't be kind of a completed constructor. You could partially, well, actually there you can't partially apply it. It would need to be fully applied there. And that's a more nuanced point that we won't get to actually ever. I haven't ever really thought about that case, but you don't write it that way. Well, actually there's good reason for that. Because if I did cons 1 and then didn't put a nil there, what type does that have? Because it's not a list. This would be a list of a function from list of n to list of n. I think we talked about that a little bit at the end last week about how constructors have types as well, and they have a function type even though they don't compute anything. We'll revisit this a lot probably. So if that's ever confusing, do say something, please. Yeah, so I'll actually leave that there. I think that's a useful note. Now, why is this useful? Like, this is useful. It saves us a bunch of definition space. We don't have to write a new definition for every kind of list now, but it also gives us something else, right? So how do I write? We wrote the length function last week. Yeah, this will be a new header. Length. And we wrote this function like so. So length took a nat list and returns a natural number, right? The length of the list. And we said the length of nil is equal to 0 or z. Did I use the shortened version, z and s? Okay, I'll keep doing that for consistency's sake. And then length of cons x's was equal to the successor of length x's. Okay, this should be familiar. We went over this last week. I think it's on your homework maybe, or maybe it was in the recitation yesterday. Now, can I write this in a more abstract manner now that I have these polymorphic lists, or these lists that don't necessarily care about what's inside them, right? So for starters, let's just rewrite this length function using lists, but not lists, but using this new notation. So the type would then be length of type, and I'm expecting a nat list here. How do I write that now in our new notation?
List and then space and then a natural number symbol.
Right on. So list, space, and then the natural number symbol. And then that still returns natural number. And is the definition going to change? It's not going to change at all. The definition is actually the same. We'll get to why in a second. So now if I wanted to write the length function but have it be polymorphic, what could I do? All I'm going to do to make this polymorphic is change this n to a. Now it takes a list of a list of anything. I don't care what is inside the list. The length is the length, and I compute a natural number from it. I don't think that's how you spell polymorphically. Oh, I think that was how you use. Yeah, that first one was right. 1 L or 2 L's? 2 L's? We'll go with that. I don't know if 2 L's is right, but we'll go with 2 L's. This is not a spelling class. Yeah, so we can do that polymorphically. Now, I could take a length of a list of numbers, right? For like 1, nope, that's not the right color. We don't have a good color for like example stuff. I'll use brown for examples. So we have like 1, 2, 3. What's the length of this? Length of 1, 2, 3 is equal to 3. Okay, well, how about the length of a string now? I'll write it in the same kind of shorthand. What's the length of this? Well, it's 5. We all know that, but we could also carry out that execution, right? So I could go and look this, if we pretend these are conses instead of the shorthand I use, this function would compute it in just the same way. Why is that? Is anyone looking at this definition, why were we able to make this polymorphic? And wrong answers are great here. Just take a stab at it, somebody. Why were we allowed to do that here without really changing the definition at all?
It doesn't care about the data type of the elements, it just cares about how many clauses are in there.
How do you know that?
It's a good guess.
You're right. It is a really good guess. It's correct. But if you look at the actual definition itself, so the definition part, right, which is those second two lines, does anything change? No. Does it use anything about the numbers in the list? No. It doesn't ever use a constructor for the numbers. It doesn't match on those numbers. It's just a list, right? We only care about the list part. And so that's what allows us to abstract. It's that list piece. I need to look at my notes. Yeah, so we can define list, but then say I have a list of numbers, right? And I want to define the sum function. So it takes like a list of natural numbers and adds them together. Could we do that? We ought to, right? Like we ought to be able to do it. I would say so. So can we do that? Can start by giving me a type. What's the type of name and type of this function? So let's go through that list, So what's the first thing we do? We always give a function a name and a type signature right away. It's the first thing we do. What's the type of this function? Takes a list of nats and outputs a natural number, the sum, right? So we write that as list of nat, and it outputs a nat. Looks a lot like the length function. It's different though, right? Now, how do we write this function? What are the cases? So we start by writing that most general case, right? So sum equals, and we have a whole where we have list of nat to nat, squeezing it all in there real tight. I better not. I better write it better than that. And that's our whole. Okay. The big bar there. What can we do here? Well, we're going to introduce a variable, right? That's the first thing we're going to do. So introduce x's. And now my output is expected to be nat. From here, where do we go? What step can we take? It being a list function, what else can we do? Well, we can define, we have two options, right? That list, that cheat sheet I gave you, and it's online too, it's on Canvas if you guys want to look it up. It's in, I think, last week's overview. I could take one of three steps. I could introduce more variables. We can't here because we just expect an output type. So we can't introduce any more variables. Or we could split variables we do have introduced on the left-hand side, or we could just define the output. Can we define the output here? Oh, so you're getting into cases now, right? So we ought to split the cases apart, right? Right on. So let's do a case for nil and a case for cons. And again, I'll call the variables for cons x and x's, where x's is more than one x, right? Now, what were you going to say nil was? What's the sum of an empty list?
Right, 0.
0, right? I like that. Okay, here's the hard part. What's the sum of a non-empty list? Yeah, so there's a question online. What does X's stand for? It's a list that it typically, we'll call it X's. It usually mean, it's always pretty much going to come into this context where you have an X and an X's, where X is the first element of a list and X's is the rest. XS, it's not like a formal name. You could change that to like the rest. You can call it anything you want. These names are, you pick them. So, you know, you definitely don't have to write it in this style. It's just convention. We usually write it that way. Yeah, and Arthur gives us an answer here for the second case. And he says it is the highest term plus the sum of the remaining list. I think by highest, he means the one in the front of the list. And now, how do we write that formally? We're going to write plus X. I'm going to have to move this over a little bit. And then sum X's. So we're making a recursive call there. Yeah, and Arthur elaborates the highest and say the stack, so to speak. Thanks for elaborating on that. But yeah, I understood what you meant. Yeah, and so we just add those together. Do we think that, does that seem right? Anyone skeptical? I think we should do an execution here just to show it works right. So again, this is the reason I do these executions is it's a good way to check yourselves. Even on paper, you can do this really fast. So let's do that. So let's do sum of cons 4, cons 3, nil. Okay. And I'll walk you guys through this one real fast. What does that equal? Well, if we look up the definition, do we see a nil? No, we see a con. So we look and match on that case. And it says whenever we encounter a cons case, we replace it with this. So now it's plus 4, because that's in the X position. And then sum of cons 3 and nil. Everyone with me so far? I didn't make any jumps that scared anybody. Anyone doesn't understand, we're following so far. Cool. Now we could try and evaluate that plus 4. It's not going to work. So let's just keep working on that sum piece. So now this part is going to be, let's work it out. So it's also evaluating on a cons there. So let's keep the plus 4 around. And then this part's going to become this. So plus 3. And then the rest is sum of X's. Well, we still have an X's here. It's sum nil, the empty list. Okay. Now let's finish executing the sum part. So we have plus 4, plus 3. And what does sum nil give us? 0. Okay. Now can we execute the rest of this? Pretty easily by hand, right? So this is going to be giving us plus 4 and 3, because 3 plus 0 is 3. And now we just do plus 4, 3, which is 7, which gives us kind of a final result here. Okay. That's how, remember, that's how we execute the functions. All we're doing is matching the left-hand side piece to the right-hand side piece. Okay. If you're ever stuck, this is a really good way to kind of check your work. You can execute this by hand and see where it went wrong. It's going to be a really handy tool. You could also, sometimes, and it's very rare this works, sometimes you can do, say right here, the plus 4 first. That does work sometimes. Not always. We'll see, actually, I think tomorrow we talk about a special kind of recursion that will always let you do that. Actually do reductions as you go, because this is kind of wordy. Anyway, I'm getting ahead of myself. Questions about that execution? 7 is right. I mean, 4 plus 3 plus nothing else is just 7. So now we can add a whole bunch of stuff together, right? We have this like super plus function called sum. Where was that going? Okay, so now if we look back up at our type definition here, we had that as a list of n to n. Could I abstract that and make it a list of a to n? In this situation, could I make it more polymorphic?
No, because it's actually looking at the number versus the quality.
Right, so it's looking at the number, not just the list, right? So it's actually kind of digging inside the element and saying, okay, I'm gonna do something with you now, and I'm gonna add you together. So in some situations, you can make functions more polymorphic, and in others, you cannot. This is really important going forward, because, and it will trip some of you up, is like, okay, well, I wrote length, or say sum, can I make it more abstract? Sometimes you can't, and that's good. Like, you don't want it to be. Like, you don't want to just add up anything. You want it to be in kind of added up numbers, right? Questions so far, chat? I'm going to let you have a second to type stuff in if you do have any questions or got lost there, and we can go over that. Because I need to find where I am in my notes. I went a little out of order. So far, we're looking good. So we have these lists, and I just some more practice with writing these kind of functions. Can we write the following function? So I'm going to give you some examples, and I want us to work this out as a class. So this is going to take, I'm going to call this function tail, and tail of cons 3, cons 2, cons 1, nil. Evaluates to cons 2, cons 1, nil. Okay, I'm gonna use shorthand for the rest of these. Tail of hello is hello. And tail of, let's do tail of nil maps to nil. Is that a function we think we could write? It is. We have all the notation for it. Let's try and write it. I'll give you guys a minute or two to try it on paper for yourselves, because usually we go kind of fast. So take a minute or two, try and write how you would write that function out, okay? In a second, I'll ask questions as we go to kind of keep people at some milestones. So I'll give you a second. Remember, step 1, there's always something we do at the beginning. Start with that. I'll give you guys probably 4 or 5 minutes to take a crack at it. And feel free to ask questions in chat and online if you have them as you go. Oh, Galwa asks what the bar arrow equals. That means evaluates too. It's just another way of writing equals, basically. We usually use it as notation for talking about evaluations. And mathematicians really like that notation. Okay, so can we start? And there's an answer in chat that I like. But let's work it out from the beginning. So let's start by giving this function a name. We already have the name. I gave it to you. It's tail. And what's the type of tail?
List of A to list of A.
List of A to list of A. Okay. But we start out by writing the general case, and we're going to case split. So I'm just going to save us some time, and Linnea has saved us a lot of time. So we have tail of nil equals something, and tail of cons x's equals something else. And Linnea says, for the nil case, we are still stuck with nil, and that makes a lot of sense because we have it right there. Right? We don't want it to be anything else. That case is pretty decided for us. And then our second case, it's just going to be x's. Okay, it's just taking the top off and giving us the rest, right? Yeah, I guess that was mostly practice. I'm trying to think if there are any other remarks I want to make on this function. Yes. Because cons x's would be expecting another element. So if you think about it, when we crack this x's open, it's either going to be nil or have more con stuff already. Like it'll already have a con kind of inside it, if that makes sense. Any other questions about this problem? There are similar ones. So we could also write something called the head function, which takes just the first element of the list. How are we doing on time? Yeah, we can introduce this. We got a lot of time left. So let's do the head function. So similar exercise where head of, I'm just gonna use the shorthand here, 1, 2, 3 is 1. So it's basically the rest, right? So tail and head kind of have a relationship to each other. Head of hello maps to the character H. You could do a whole bunch of other stuff. I think this gets the point across. I'll give you guys a minute or two to try and write that function. Should be pretty straightforward for the most part. Anyone have a solution yet? You do? It's written down? It's written down? Interesting. Okay, so let's get started before any of you gonna get too far along. What's the type of this function gonna be? What's the type?
I said list of A to just A.
Yeah, list of A to A. I like that. Okay, that's right. Let's try and define this function. Okay, so we have some cases. What are our cases here? So we have a nil case. Do we have other cases? Yeah, we'll have that cons case as well. Here we're expecting an A, and then this hole we're expecting an A. What do I fill those holes with? Let's start with the cons case this time, go out of order. This one's just going to be X. Okay, how about the nil case? Could it be nil?
Yeah, I guess it depends on your data type.
Does it depend?
Well,
I would imagine it's nil.
So we have some people saying they think it might be nil or it should be nil. What's the type of nil? So here, I'll just give it to you. Nil has type list of A. What's wrong with that? Can I put that there? No, I'm expecting, I have a hole for an A. It can't take a list of A. That's not allowed. So what do I put there? I can't put A, that's a type. Do I have anything I can put there? Is there anything we've defined in this class I could put there? No, there's nothing. Can't put 0, can't put anything there because it won't have type A, right? A is not, we're not allowed to say anything about what type it is. Okay, it's constrained. So in order to fix this, we're going to use a little bit of a cheat. So to fix this, we need to define a new type. Now, why is this problematic? Let's talk about that for a second. Why can't we define head for an empty list? It's kind of in plain English. What's wrong? If I try and go for it, you're about to say it. There's nothing there, right? I can't take an element that isn't there, especially when I don't know what's inside the list. If I said list of gnats to gnat, I could have a default value, right? I could define a default, but I would have to constrain it down to be a list of gnats. But this function clearly is applicable to a whole bunch of different kinds of lists, right? Sorry, I was catching up on chat. Pseudo, I'm not sure where you were going with that. If you could elaborate. While you do that, I'm going to keep going now. So we need to define a new type. What's this new type going to be? Well, we need to capture basically this idea of there maybe being a value there. So in this case, head of nil is nothing. There's no value, right? And in the case of head of cons, we do have like just this X, right? So let's just use that language I just used to write a new type. So we maybe will have a result. So let's call this type maybe. Maybe will be polymorphic, so it'll be maybe A. And we define to maybe A to be either nothing, so that's a new constructor, or just A. Okay. So it's kind of like a list in some respects, right? It's kind of saying like, okay, well, you got something or you don't have something. There's a little polymorphic term wrapped inside it. And we can use this for the situations where there might be a value, there might not be. Okay, and now do we think we can define head in this way? Let's start right off the bat before you guys try and write anything. We need to change the type of head. So before head was list of A to A, how will the type of that change? We're still taking in a list of A, but then what's the output going to be? Yeah, it's going to be a maybe A. Now take a stab at defining that. I'll give you guys a couple minutes. I've been rushing us the first few days. Usually I give you guys some time to work stuff out. So try defining head using maybe as the output type. We got an idea? I don't look away when I look at you guys. You guys have to read the room to tell how chat's doing too. We got some people getting smart in chat and saying maybe. Let's take a stab at this. So what's the nil case going to be? Nothing. I like it. Why not? So the nil case, it's just going to be, nope, not eraser. It's going to be nothing. Right, now we have something that can fill that hole, right? Because now and if I should have put a hold notation there. So we're expecting a maybe A in both of these holes. Right, and you said we need to replace that hole with nothing, right? Nothing is a type of maybe A. And what goes in the other case? What goes here? Don't overthink it. There's
X.
just X?
Sure.
Just X or just X?
I wrote X.
It's going to be just X, right? Which is going to be the confusing part of trying to speak this out loud. Just X. Instead of just the letter X, it's actually going to be the constructor just in front. So now we can think of a maybe A as being like this special augmentation to A, maybe, where it's like, okay, it's this type plus this default value. Do we have this in other programming languages? Do we have a value that's kind of like nothing in, say, C? Kind of like null, right? Like null's very similar. So there is a relationship there. It's not super formal, but there is. So null kind of is your default or nothing value in C-like languages. I don't know if Python uses null. They probably do. Yeah, Python uses null. This is exactly the same. So it's just us being formal about it. Instead of assuming A has a default value, we say, oh, it's just nothing. It's nothing. Then we can start defining functions on maybe to process this safely, right? So oftentimes you'll have null, and you need to usually do a null check to make sure your program doesn't crash. If you try and like do a computation with a null value, it'll freak out. In this situation, the type system is actually going to force us to write functions that are safe, that check if it's a just or a maybe or a nothing in every situation. We'll get more practice with this later. This is how we fix the head problem. Okay, we'll apply this later. There's going to be a little bit more maybe where we use head. And now how do I get the number inside? I can case match, right? So it just becomes more application of the same few principles we've been talking about, just applied here. Yeah, so a couple questions. So Linnea asks, are these real constructors? Well, yeah, they're real. We defined them. So in programming languages, especially in this class, we'll define every constructor we use ourselves. What Scala is really good at, what other functional languages are really good at, is letting you define the data you need. And that's what we've just done here. Is we needed a data type to represent failure, right? It's a case where the function doesn't return anything. And maybe captures that perfectly, really perfectly. You know, we define the numbers, we define the Boolean. We're allowed to define all that stuff ourselves. So there's also a built-in in Scala called, I don't think they call it maybe, they call it something else. What do they call it? Not possibly. It is another synonym though. They might call it maybe, I don't know. What? It's not could be, that's 2 words. We stay away from that nonsense. Yeah, and then Ben Spicer asks, why do we need the just constructor? So this is a good question. So in this function, I'm gonna have a hole here. And if I look at the output type of the function, it's a maybe A. So my hole is of maybe A. What type does X have? Yeah, X is of type A, not maybe A. So I need it to be a maybe A, and that's why I put the just in front. Very, very good question, Ben. So that's kind of what's making it in that other type. Actually, I'll leave that note there. That's a good note. I'm just going to change the color of it. Does that clear up your question, Ben? I hope so. Why is it used in maybe A then? Oh, because it's a constructor in maybe A, right? So the just A is what lets us tell it. It's like, this isn't just an integer, it's just an integer, right? So pardon the kind of reuse of that word, but it's what kind of, cast isn't the right word, but it's sort of what lets us cast it into the maybes by wrapping it inside this constructor. It lets it kind of like be a member of that set. Okay, one last problem. This won't take the rest of our time, so you guys will get out a few minutes early today. So this is kind of taking polymorphism as far as it'll go. And my question for you guys is, I have this type declaration. And this isn't the name we'll leave the function with. This is the name, we'll just call it F for now. F is of type A to A. My question for you guys is, Actually, I'm gonna ask, does f exist? Linnea says she thinks not. Does anyone else have any other thoughts? I understand why Linnea would think that. It's a very good reason to think that.
There's no like universal operation you can do something and have it come out as its own.
Yeah, so there's kind of no universal kind of operation that we could apply to everything, you're saying?
Yeah, and have it all like you can't do
Ooh.
the same thing to a natural number.
Is that true? I actually don't quite agree. I don't quite agree. In a philosophical realm, you're sort of correct.
Okay.
So you're not wrong, but that what you just said, we can't do anything to a function or do anything to everything, isn't the same as saying there doesn't exist a function. And you equated the two.
Okay.
Yeah, and Ben comes in with the answer. This function has a name. You guys have heard this function's name before, probably. We call this, I'm going to add some exposition here. I'm just going to go ahead and define the function, actually. So what do we call this function? It's the identity, right? The identity function. So we'll actually, from now on, always call it ID. Type A to A. And the function is IDX equals X. And now how you might work with this is if we kind of follow our process, this is going to be a hole of type A. And your question then becomes, can I fill that hole? Right? It's like, is there something I could put there? Well, sure, X here, that's of type A. So I can put it on the left-hand side, right? Or the right-hand side, rather. Which is why I was kind of nitpicky about what you said, is because you said we can't do anything with it. But being able to do something with a function is entirely different from saying there is a function, right? So it's kind of very semantic nitpicking, right? This does nothing, right? It's just the identity function. But it's not super important for computation, but it's super important for doing proofs on stuff and for talking about your type system. And there's a reason why this function exists, but it's not super interesting to us as computer scientists because it does nothing. But this whole exercise is really to point out there's a lot of kind of very well-defined functions that kind of seem like they don't need to be there, but they're there for a good reason, for kind of mathematical purposes. And in this situation, it also exhibits how a lot of times when we write functions, there's only one way to write it, which is a really interesting notion. In most cases, there's more than one way. In most. But in some cases, there's only a few possible answers to a solution, which is why that list of kind of steps I gave you the other day is really powerful. Is because if you follow those steps, you will always get at a solution. Now, there's a lot of undecidability in some of the points, but like it works. Even here, where we thought we couldn't define the function, you definitely can. Questions about anything we went over today? Really good discussion today, guys. We'll pick up with a slightly different topic tomorrow. It'll be somewhat related, but quite a bit different. Talking more about how we evaluate functions. But otherwise, I will hang out for a few minutes if you guys have questions. Otherwise, get out of here. Have a good evening. And I'll see you same time, same place tomorrow.
Was theoretically about that, where there's no operation.
I'm gonna say you were philosophically right more than anything else.
Okay, okay.